Right, this is Chapter 4, Summary Notes. This is the section on the historical development of the atomic theory. Dalton proposes the first modern atomic theory, and it's based on many other scientists' work. And he puts together this theory that atoms are the smallest particles of matter, and they are indivisible. All right, also indivisible. And you can't break them down any further. All right, as we go through these, think about how many of these things might have changed today with the reading that you do in this chapter. All right, something else in his theory: all atoms are of the same element, and they're all the same, and atoms of different elements are different. All right, that's also part of this statement. Okay, do we know that's still true today? We'll see. All right, so compounds are made up of two or more elements. Now, Dalton did a lot of work on this one himself, so we have to give him credit for that. Atoms of different elements, this last one, can rearrange to form new substances, but can neither be created nor destroyed. We know that today is the law of conservation of mass, and a scientist named Lavoisier actually helped to contribute this part of the atomic theory that Dalton has incorporated. All right, so that's the first atomic theory. That's 1800. Thomson is around 1900s. The date's not on here, but again, this is 100 years later when we now know about subatomic particles. All right, he discovers the electron by using what they call a cathode ray tube, and you can see some of that in your textbook. But he thinks that these electrons are floating around in a positive sea of charge, which is the pudding part of this plum pudding model. Okay, very simple to imagine. Okay. All right, Rutherford, he's about the same time period as Thomson. They're both working over in England. Rutherford discovers the nucleus of the atom through this gold foil experiment, and I'm going to use a little red pen, maybe a blue pen to help offset what's already here. All right, now here's the gold foil right here in the center of this screen, the circular screen. Over here to your left is a source of radioisotope that puts out what we call a helium nucleus, and we'll see this in the next chapter. A helium nucleus is, well, this is the helium atom. A helium nucleus is just of two protons in the nucleus, and two neutrons together make this mass of 4. And it's just the helium nucleus. The electrons have been removed. And it goes, many of them go straight through. All right, so if we go over here to this larger cross-section of the film, the gold foil film, you see many of these lines are coming straight through, but occasionally some of these get deflected, and they get deflected because they're hitting that positive dense nucleus. So it gave a rise to that notion of a positive dense nucleus. It also gave rise to the fact that the atom was mostly empty space. Okay. Positive dense nucleus, mostly empty space, and that electrons that are there are outside the nucleus. All right, and they actually orbit the nucleus, kind of like our planet orbits the sun. Okay, we know that's a little different today, but it was pretty good for back in the 1900s. All right, so here's a nice cross-section blow-up of lithium metal in this petri dish. So we see the lithium atoms together in the metal. All right, and then we're zooming in on a lithium atom itself with the nucleus being so tiny. Compared to the diameter of the atom being 10 to the minus 10th. The nuclear diameter is 10 to the minus 15th. Okay, so there's 5 powers of 10 difference in space. All right, so that's why we say the atom is mostly empty space. Okay, and again, the neutron was discovered later. They knew that it was there. They just didn't realize exactly what it was until some advances in technology. All right, so there's just a summary chart of the three subatomic particles and their symbols, their charges. The proton and neutron are about the same mass. The electron is so teeny tiny compared to the other two that it's considered negligible. Okay, and we don't even incorporate it in the mass of the atom. All right, so can you match the subatomic particles to the description that's here? You can stop the video and then come back and check your answers. All right, something found outside the nucleus, that will be your electron. Okay, something that has a positive charge and identifies the atom will be the proton with a positive charge. The neutron has no charge, but it does have mass. All right, so those are your three particles. All right, question 4 says atoms are neutral. Electrons and protons are equal to each other. So if an aluminum atom has 13 protons, then it should have 13 electrons. All right, so the atom becomes neutral. All right, positive charges balance the negative charges. All right, again, try these as well. Just stop the video and then come back, and we'll cover these in just a minute. All right, nitrogen is element number 7. So it's going to have 7 protons and 7 electrons. All right, zinc is element number 30. It's going to have 30 protons and 30 electrons. Sulfur is element number 16. So it's going to have 16 protons and 16 electrons. All right, notice this is how an element is identified. The atomic number equals the number of protons, and it tells you the identity of the element. All right. All right, so we have gone from Dalton's atomic theory. All right, let me scroll back up so we can take a look at that theory one more time before we close this out to wrap it up. Are atoms indivisible today? Yes, they are, because we know about protons, neutrons, and electrons. All right, so that part of Dalton's theory has changed. Atoms of the same element are the same. Atoms of different elements are different. All right, we're going to see in the next video that this also has changed. We know that compounds are made up of 2 or more elements. That stays the same. And we know that today we know, yes, that a substance can neither be created nor destroyed, but we know that energy can turn into pure matter, or matter can turn into pure energy because of Einstein's theory and nuclear material. Okay? So those are the parts that have changed. Other parts have stayed the same. And we will stop it there. All right, atomic number of protons tells you the identity of the element. All right, see you in the next video on isotopes.